Astrobiology is the study of the origin, evolution, distribution, and future of life in the universe, extraterrestrial life and life on Earth. This interdisciplinary field encompasses the search for habitable environments in our solar system and habitable planets outside our solar system, the search for evidence of prebiotic chemistry, laboratory and field research into the origins and early evolution of life on Earth, and studies of the potential for life to adapt to challenges on Earth and in outer space. Astrobiology addresses the question of whether life exists beyond Earth, and how humans can detect it if it does. Astrobiology makes use of physics, chemistry, astronomy, biology, molecular biology, ecology, planetary science, geography, and geology to investigate the possibility of life on other worlds and help recognize biospheres that might be different from the biosphere on Earth. The origin and early evolution of life is an inseparable part of the discipline of astrobiology. Astrobiology concerns itself with interpretation of existing scientific data, given more detailed and reliable data from other parts of the universe. The roots of astrobiology itself, physics, chemistry and biology, may have their theoretical bases challenged, although speculation is entertained to give context. Astrobiology concerns itself primarily with hypotheses that fit firmly into existing scientific theories. The chemistry of life may have begun shortly after the Big Bang, 13.8 billion years ago, during a habitable epoch when the universe was only 10 to 17 million years old. According to the panspermia hypothesis, microscopic life, distributed by meteoroids, asteroids and other small solar system bodies, may exist throughout the universe. According to research published in August 2015, very large galaxies may be more favorable to the creation and development of habitable planets than smaller galaxies, like the Milky Way galaxy. Nonetheless, Earth is the only place in the universe known to harbor life. Estimates of habitable zones around other stars, along with the discovery of hundreds of extrasolar planets and new insights into the extreme habitats here on Earth, suggest that there may be many more habitable places in the universe than considered possible until very recently. Current studies on the planet Mars by the Curiosity and Opportunity rovers are now searching for evidence of ancient life as well as plains related to ancient rivers or lakes that may have been habitable. The search for evidence of habitability, taphonomy, and organic molecules on the planet Mars is now a primary NASA objective on Mars. Overview. Astrobiology is etymologically derived from the Greek sigma tau rho omicron nu, astron, constellation, star, beta iota omicron sigma, bios, life, and lambda omicron gamma iota alpha, logia, study. The synonyms of astrobiology are diverse, however. The synonyms were structured in relation to the most important sciences implied in its development: astronomy and biology. A close synonym is exobiology from the Greek epsilon chi omega, external, beta iota omicron sigma, bios, life, and lambda omicron gamma iota alpha, logia, study. The term exobiology was coined by molecular biologist Joshua Lederberg. Exobiology is considered to have a narrow scope limited to search of life external to Earth, whereas subject area of astrobiology is wider and investigates the link between life and the universe, which includes the search for extraterrestrial life, but also includes the study of life on Earth, its origin, evolution and limits. Exobiology as a term tends to be replaced by astrobiology. Another term used in the past is xenobiology, a word used in 1954 by science fiction writer Robert Heinlein in his work The Star Beast. The term xenobiology is now used in a more specialized sense, to mean biology based on foreign chemistry. whether of extraterrestrial or terrestrial origin. Since alternate chemistry analogues to some life processes have been created in the laboratory, xenobiology is now considered as an extant subject. While it is an emerging and developing field, the question of whether life exists elsewhere in the universe is a verifiable hypothesis and thus a valid line of scientific inquiry. Though once considered outside the mainstream of scientific inquiry, astrobiology has become a formalized field of study. Planetary scientist David Grinspoon calls astrobiology a field of natural philosophy, grounding speculation on the unknown in known scientific theory. NASA's interest in exobiology first began with the development of the U.S. space program. In 1959, NASA funded its first exobiology project, and in 1960, NASA founded an exobiology program, which is now one of four main elements of NASA's current astrobiology program. In 1971, NASA funded the search for extraterrestrial intelligence to search radio frequencies of the electromagnetic spectrum for interstellar communications transmitted by extraterrestrial life outside the solar system. NASA's Viking missions to Mars, launched in 1976, included 3 biology experiments designed to look for metabolism of present life on Mars. Advancements in the fields of astrobiology, observational astronomy and discovery of large varieties of extremophiles with extraordinary capability to thrive in the harshest environments on Earth, have led to speculation that life may possibly be thriving on many of the extraterrestrial bodies in the universe. A particular focus of current astrobiology research is the search for life on Mars due to its proximity to Earth and geological history. There is a growing body of evidence to suggest that Mars has previously had a considerable amount of water on its surface, water being considered an essential precursor to the development of carbon-based life. Missions specifically designed to search for current life on Mars were the Viking program and Beagle 2 probes. The Viking results were inconclusive, and Beagle 2 failed minutes after landing. A future mission with a strong astrobiology role would have been the Jupiter Icy Moons Orbiter, designed to study the frozen moons of Jupiter, some of which may have liquid water, had it not been cancelled. In late 2008, the Phoenix lander probed the environment for past and present planetary habitability of microbial life on Mars, and to research the history of water there. The Curiosity rover is currently probing the environment for past and present planetary habitability of microbial life on Mars. On 9 December 2013, NASA reported that, based on evidence from Curiosity studying Aeolus Palus, Gale crater contained an ancient freshwater lake which could have been a hospitable environment for microbial life. The European Space Agency is currently collaborating with the Russian Federal Space Agency in developing the ExoMars Astrobiology rover, which is to be launched in 2018, while NASA is developing the Mars 2020 Astrobiology rover and sample cacher for a later return to Earth.